Yeah. All right. Yeah. So I figure we just.
Oh, look who it is.
Oh, here we
Someone-
go. Here comes Jen. Hey, Jen, how's it going?
Jen.
We're live right now, just so you know. So
Oh,
no, don't share any top secret stuff or I don't
the
know what.
meaning of life is 42.
Life is I'm actually turned 42 this year. I'm 42 years old.
That's a cool age.
Yeah.
Wow.
There's like certain like nerd marks of age. One was 37 because I'm not old. I'm 37. I don't know who gets that. That's a Monty Python part of a Monty Python skit.
That was pretty
With
old.
old woman, man. I'm not old. I'm 37. And then I think 42 is,
Let me post a note on our channels that we're live. So what are we kind of covering today? What's your goal?
So so we've got angles calculating correctly last time.
Nice.
So now we're going from angles to forces. So let's just I want to show where we're at. And let's start there.
All right. So for the description, because I'm going to post this in our Facebook groups in a minute, I should say Eric and Jen are continuing. Right there. And what are you calling it? What are you calling the widget you're building?
The crank slider DAC, or data acquisition. That's what DAC stands for.
DAQ.
Uh-huh. And if I run it here, you'll see. Yeah, so we've got position, velocity, acceleration, and theta all. And the theta is the angle between the slider and that linkage. I'm going to go ahead and pause.
You guys have built this from scratch, right?
Yeah. Cool. It's been so fun. I think I'm just going to first, these plots are just moving a little fast for me. They're giving me, I'm going to go ahead and just as a little primer, let's go ahead and change how many points are in that plot. That's really easy. We made this data length variable. Let's make it like 500. Let's see how that looks. Well, that's a little slow. 250. Let's make it 250. By the way, if you wanted to make it zoom in and zoom out, all you do is wire up to the scroll wheel and then change this variable.
Oh, I think you're not sharing that screen.
Oh, I'm not sharing my screen. Got to go back. Thank you, Edmar.
I thought we were supposed to imagine what it was supposed to look like.
There you go. Oh, you know what? And as part of my prep, let me just make a quick change here.
Oh, welcome, Daryl. We got a few people watching now.
Yeah.
Twin Snakes.
Oh.
I think he was an active participant in yesterday's live stream too, when we talked about sim-ready assets.
Oh, cool.
That was a fun one with Bo and Ashley. Your colleague was on with us.
There we go. Just change my resolution so it's easier to see.
Yeah, it looks good.
What I got here. And let's go back here. I'm going to undo everything I just did. We're going to go through it again. So I just want to show we've got position, velocity, acceleration, and theta, the angle between the link and the slider, all working like a charm. And then I was just saying that these plots are just moving a little fast. They're kind of a little fast for my taste. So went over to the extension, and we've got this data length thing right here. And I was just saying, if you wanted to like kind of create a zoom in, zoom out effect on that plot, all you have to do is use carb, the UI, or the carb is what you use to like for basic UI stuff, and to tap into the mouse events. You could tap into the scroll wheel event and let people scroll in and out and just change this data length variable. That'd give you like a pretty quick and dirty approximation of a zoom in, zoom out. So, okay, we're saving. That's saved. Let's run it again, see how that looks. Yeah, I think that's more like it. So now all we've got to do, and I think I might remove some of these plots because I don't think we need all of them. I think I might go ahead and remove or just replace the position in the velocity plots. And next we're going to take this acceleration and we're going to calculate mass times acceleration of this slider at every step. So mass, I wonder, let's start with, I just don't know what the mass is, right? But we just got to figure it out once. Let's take a look at that slider. And I just wonder if we get any of that in here. Let's see. Not really, right? Let's take a look at, let's find, here's this mesh. Refinement corner. Here we go. Here's my collider. I'm just taking a look. Let's take a look at the mass maybe. Well, first let's change that. Let's, if I go to window, is there a physics authoring? Physics. Here we go. This physics authoring toolbar is kind of nice because we can, I think we can make our physics inspector. Oh dear. Somewhere you can make the colliders visible. Let's see. No, that's not what I want. That's not what I want. No. It's all right. Somewhere there's a setting that lets us. Oh. I did something wrong. I broke it. I'm just going to reopen it. And we'll have to hot reload this. So all I'm doing right now is we've got this slider right here. And I need to know its mass properties. And this is, I think, a good, let's see what if we have any. Yeah, great comments. Mass will also be important for sim-ready assets. Absolutely. And if we go to the properties of this mesh, we should have, we've got a rigid body here, right? Then you've got the collider here. But I think we can go to this rigid body. We can add physics. No, it's to the collider. So if we go to the collider, which is on this mesh, we can say add physics, and then there's a mass option. So I've just added a mass to this. And let's take a look at that and see what info we get. Yeah, and so the mass is auto-computed in this case. And here, because of the way we're doing, this is kind of like half with simulation, half by hand. And so if we were making a sim-ready asset, then we would absolutely calculate this mass and input it right here. In this, we got the mass, density, center of mass, all of those. So you can set your mass that way. In our case, we just need to calculate the mass once. So let me open NX here. And let me find this. I got to find the CAD. So let me dig around a bit and find my CAD. There it is. I've got the CAD off to the side. And let's see here. All right, let me just open that model. Moving part, I believe, is what we want. And I'm opening it off to the side. Just don't always want to show all my folders and files to everybody. All those top secret projects, guys. Too cool to show on even this live stream. Let's see. And then solid. There we go. Moving part. Okay. I'm opening it now. So just bear with me for just a minute. Here we go. Great. I get to use my space mouse. Don't know why it's red in here. There we go. We just need to like have a disclaimer that you have to sign our NDA before you can watch the live streams. So if we look at this, man, I have not used NX a ton, but I bet if we go to tools, let's go to properties maybe. Just need either the volume or the mass properties. Mass. Come on. Why isn't it doing that for me? You know what? These are SolidWorks parts. I'm just going to reopen in SolidWorks. So just give me a switching CADs. These were originally designed in SolidWorks, and so I'm hoping we can get the mass properties a little bit easier in SolidWorks. Seems like there's a pretty good chance of that, right? Let's see. That's more like it. Now it's actually like a part with features and stuff. Now we go to evaluate, I think. Mass properties. Now we're talking. Yeah, we got some fun comments coming in. None of us are too cool for school. School is our favorite, right? We love to learn. I just want. And what's this? I've never used Moi 3D. I've used Fusion 360. It's a good one. Another good one, if you're in that Fusion 360 looking for more of like a personal CAD, is Onshape. It's a web-based CAD software. They have a really open free tier. So as long as you share your parts publicly, you can just use it. It's pretty cool. But Fusion 360 is great for startups. If you've got a startup, you can get basically a license for so long. And Omniverse definitely has a good CAD converter. And yeah, but let's look at these mass properties. Density. So there's no material applied. So it's saying here density is 0. Usually what they'll do is then assume that if you use CAD, so if you don't apply mass properties in CAD, it will typically use water, the density of water for your mass properties. So be careful for that. That one's definitely caught me before. But what we really care about is this volume in cubic millimeters, which is a little bit odd that it's in cubic millimeters, but why not? Let me open up a web browser here. We'll do. What should we make this out of, everyone? Yeah, the density of water. What's even weirder is sometimes if you measure, you got to be careful. Some CAD softwares, if you have surfaces in your model, it will assume that they're 1 millimeter thick and include the surface area times 1 millimeter thick for all of your surfaces. So you really got to be careful with these mass properties, folks. Make sure you know what's going on. Fortunately, we're just doing a demo thing, so I'm not being so careful. But when I was an aerospace engineer making airplanes fly, that was really important to make sure you were getting those masses.
I think it would be important.
Yeah. So if you had, you'd have all these surfaces that were the density of water because they didn't have a material applied, and there was just like bajillions of them because you're designing. So you have all these like reference surfaces in your CAD part, and so your mass would be 10 times what it was supposed to be and be awful.
Wow.
Yep. All right. So we've got this density in cubic millimeters right now. And we're going to, let's see, let's make it out of like a 6061 aluminum. That's like a nice aluminum that's not so expensive. It's like 7075, but it's got good properties. 2.7 grams per cubic centimeter in grams per. There we go. Try that one. No, we're going to have to convert. Oh, dear. Wait. Cubic millimeter, right? Oh, dear. We're not going to go to that one. That's a dangerous website. All right. We're going to make a new tab here. And I wonder, should we just do a little... I just love just trying out ChatGPT sometimes. Let's just see how let's just try it out. I'm curious. Oh.
You might have a little bit struggle because there's so much traffic going around right now.
Oh, really?
Yeah.
Have you noticed, like, just because the time of day it is, or?
No, I've had certain people come on Discord asking about the room generator. So
Oh, it's not working?
it's because there's so much traffic going to the API. You might be able to get it. Sometimes I get it, but it might stumble a bit.
Oh, come on.
Depends on the question, right? Like if you're asking for like really long paragraph.
Just use my personal. There we go. Let's see. If I have a object that is that many cubic millimeters and its density is let's try it. Probably won't work, right? This is a little tough, I would think. What is its mass? What? This is just me being lazy, right? Wait. Yeah. Oh, it actually did some algebra. That's kind of cool.
It's very cool the way it explains each step.
Yeah. What's this? Yeah. So physics will calculate mass based on volume. Yeah. What it does is if you have a material applied, right, with it which can have physics properties within Omniverse, and if you have an accurate, pretty good mesh, the physics will totally try to get the mass. But the CAD mass properties are typically more accurate than what you would get out of Omniverse right now. But I think that's good enough for me, though. 197.55 grams. Let's just say 198 grams. Let's just say 200 grams, right? I mean, how accurate do we really need to be here? I'm like, it's funny when I use these like ChatGPT, sometimes I'm just blown away like I just was now. I'm just really surprised it can do that. And sometimes I'm like really kind of like, oh, it can't do that simple thing. That's kind of funny. I'm still a little bit figuring out the whole how good is GPT thing. Okay, let's make a variable here. Self._slider mass equals 200 grams. And let's see here. Let's hijack this. I'm going to take this velocity one, or that, we'll just start with position. We're just going to start getting rid of some of these. We've got more than we need. I don't really think we need to track the position anymore. Oh, just a second. Didn't grab enough. take this position plot and put it below our acceleration plot, but before theta. I'm going to call this we're going to call it slider force. And this is just going to be the oh, I didn't actually check GPT carefully. It might have been, did they give us some garbage? We should probably run it through the check, right? Let's see how many. So a millimeter to a centimeter is like 2 spaces. Yeah. 1, 2, 3. Oh, look at that. 70. Oh, I think this might be wrong because let's see. Centimeters cube or millimeters cubed. See, cubic millimeter to cubic centimeters. Oh, what am I doing wrong? I'm trying to check it and I'm getting it wrong when it's getting it right because I'm looking at that and it's how many decimal places off? 1, 2, 3. Oh, cubic, not squared. Yeah, that's right. Yeah, it looks all good. Awesome. 2.7 times 73. Does that pass the logic test? Yeah, it's looking good. Okay. Back to trusting AIs, I guess, because it did it right. So the slider force, we're going to call this, can I refactor right here? Rename symbol. Slider force data. Let's see if it worked. Is it here? No, it didn't work. So we got a acceleration. Oh, wait, what did it didn't change it here either. Oh, that's annoying. And then let's change that data name. Yeah, I mean, someone was saying that Bing works pretty well. Yeah, Bing is using GPT in the background, so they're really pretty similar. I think Bing has just maybe had some checks and things and doesn't allow you to do certain things. Like, for example, I asked to write a letter to my boss asking for a raise, and Bing said, "I'm sorry, Eric, I can't do that for you. But here are some tips if you want to write one yourself." And whereas I think GPT would just do it. Here we go. We're just getting this plot's name changed. And now here, okay, now we don't need this transform anymore, or do we? Let's see. We don't need this one anymore. We're just going straight for velocity. Okay. And then oh, let's go back a bit. I have to grab that Prim still, don't I? All right. Slider force data is no longer around. This is getting the velocity, appending it. This is getting the acceleration. Okay, so now we know we've calculated the acceleration right here, which is just the velocity divided by the change in time. So now all we got to do, force is equal to mass times acceleration. And we know it's only moving in that x component. So it's really pretty simple. All we do is self._acceleration times self._slider mass. But it's going to look exactly the same, right, as the acceleration plot. It's just bigger. And so we'll even go to the slider force plot, and let's just make sure it's going to make it times 200. So that should be the range now. And when we run this, they should look like just dead ringers for each other. Uh-oh. We got a position data hanging out somewhere that's causing us an error. Probably where I was clearing, setting the length of the data plots. No. Aha. I want a slider for theta there now. Right. Let's take it out. Now what? Position plot. Oh dear. Got a few of these position, just changing the name. There we go. That should work now. There we go. Oh. Actually, let's stop this and debug. Why am I getting? Oh, you know what I did wrong? I changed the range from what I need to do 20 times the acceleration plot range, not 20 times the position plot range. So bad range. We want to take this one times 200. So make that a 2, add 2 zeros. And then it looks like it's the same in both directions. We'll just do that. Yeah, I love this. Loving the comments. Oh, really? This is cool. I didn't know that. You can, there's a Chrome extension that lets you talk to ChatGPT. And yeah. And then another comment yeah, this hot reload's really cool, isn't it? So I'm just editing, and then whenever I save, if you haven't developed extensions in Omniverse much, whenever I save, it just hot reloads the extension with my edits. And yeah, and so now, so since the range of the acceleration plot is 1/200th the range of the slider force, they look exactly the same. I just kind of like scaled them, and that's what they should look like. But you look at the numbers, times 10 to the 5. This is like kind of big numbers for the force. And probably in like, oh, what are my, I don't even know what my dimensions are. So we'll have to kind of sort out some units here, but at some point. So now let's figure out the force that's getting transmitted along that link. Okay. I'm going to pause it. Here we go. So we know this angle right here, that's theta. And our force is just in this direction along our y-axis. And so the force being applied to this pin is the cosine of theta times the force applied to this. And so if we divide the force of them on the mass on the y direction by the cosine of theta, that will give us the force transmitted along this link. And yeah. So there we go. So let's do that next. And where are we here? Let's go back to our code. And let's take that velocity plot right here. Let's use that one. We'll put it below the theta plot because it's kind of calculated after theta. Oh dear.
I see something interesting.
Oh yeah? What's that?
Yeah, can you create a playlist
Oh yeah, I'd love to.
and share your code
Yeah, we can do
and
that.
your model?
Yeah, all shareable. The model we got off of GrabCAD. And the code is meant to be shared. So I've been trying to get to a pretty good stopping point, but probably what I should do is just like create a repo in the future and then just have a commit after, or even a version after every show, right?
Mm-hmm.
So that you can follow along.
It's a great idea for a playlist also. So I will work on that today with Amelia.
Should we do this? All right. Let's try this again. There we go. That's the right spot. This is no longer going to be velocity. It's going to be, I'm going to call that transmission force. A car transmission, but because it's being transmitted along that link. And we're going to call this, I'm going to try to read, nah, it didn't work for me. But the transmission force data and the transmission force plot is a little different this time. Place that one. Yeah, yeah. Nope. Yeah. Yep. 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 Okay. And then grab this one and let's just replace that with that underscore. And replace all those at once. And it should just move that to the bottom. Right now it's still going to show the velocity, but let's go back. And I had that same problem here. Hot reload and let's see if it works. Yeah. Now this is wrong right now. It's not the transmission force. It's still the velocity. Let's go fix that next. Let's go to our physics loop, our physics step event. And then where are we grabbing that velocity? Here's our velocity. We still need to grab the velocity because we use that to calculate the acceleration, but we're not going to append that to any plots anymore. So here we've got this acceleration. There's the force. Here we're calculating that angle. Theta is right there. And there we calculate theta. And we want that. What's that force called? Oh, let's do like a let's see, slider force equals. Then we're going to append slider force right there. So now we have the slider force variable. When we're down here, the self dot transmission force is just going to be the slider force divided by math dot cosine of theta. Let's see if that works. See how it looks. Oh, big numbers. That makes sense because we're multiplying, we're taking this transmission force and we're making it bigger. Like it's the same. I mean, it's either 1 or bigger, right? Cosine is, or come on, where are we? We're dividing by cosine, right? Yeah. So cosine is going to be anywhere from 0 to 1. So it's going to always be bigger. So let's edit the size of this plot. Could be a lot bigger, like 30 degrees. So it could be, how much bigger could it be? 3 times as big. So let's just take these limits and go to this plot. Oh yeah, look at that theta. Oh no, theta plot. Okay, here we go. And let's make it like 6. We'll make it 3 times as big of a range here. And let's see how that looks. A little too small. Let's make it a little smaller, like cut that in half. That so we can see it a little better. Here we go. Now that is a cool looking plot. So it's kind of, as you look, it's kind of this mix between the slider force and that theta. And that is the force along that thing. Man, we're making really good progress today. Okay. Man, and an interesting discussion going on in the chat. So do you want to take a minute and just talk a little bit about?
Yeah, I guess yes. It's a good. Well, first of all, I want to really welcome Alexandra to the stream. It's so great when we see new people discovering Omniverse for the first time on these streams. So it's a great time to just chat about Omniverse for a second. So Omniverse is a relatively newish foundational platform created by NVIDIA in the last few years. It's been actually in development for much longer, obviously, but we're out of beta more than a year now. A really growing ecosystem of connecting apps kind of lets you utilize the foundation to collaborate with different apps you might use as an artist. So you don't have to sacrifice if you're a user of one app and you're working with somebody on another app, or you use multiple apps for your workflow. Sometimes it's a lot of pain points there in making sure that that things can carry over nicely. So Omniverse, in essence, kind of helps bring all that stuff together using the power of the USD so-called file format, which is, it's not really a file format, it's bigger than that, but for explanation purposes, it's I think easy to understand like that. And basically, it's a development platform at its core. So anyone can actually dive into Omniverse and build whatever you need to build, leveraging NVIDIA's core technology and, of course, GPUs. Whether you're using local setup or you're using the cloud. I just posted a link for a nice video on how to set up Omniverse for AWS. So you're not really limited to your local hardware anymore. And we announced a more full-featured Omniverse cloud program, which is in progress right now, which will let people kind of set up things in a more turnkey manner soon. But yeah, so like if looks like you're a Blender user, so there's a great, the way that it generally works is that there are different connectors. The connectors have different like kind of levels of ability depending on the application. And there's actually a customized version of Blender, which is available in the Omniverse launcher, which provides great import-export ability. So other than that, the features are pretty much on par with the latest Blender. And you can also use the non-Omniverse Blender. It just takes a couple more steps for importing and exporting. But yeah, I posted a video there, a nice explainer from Jacob Norris, who was an artist here. I think now he's working on some really cool projects in the commercial world. But really nice explainer video, just a couple minutes kind of going over some of the things. One of the crazy things about Omniverse is that the ability to collaborate not only with apps, which is really transformative, but also to be able to collaborate with other people. What Eric's doing now in this stream series is mostly working in his instance. So Jen and I are not involved for the most part inside of his application. But last week on our live stream, we showed off a platform called UME.studio, so UME Studio, which basically shows a really compelling way how different people using Omniverse can collaborate in the same scene at the same time, no matter where you are in the world. We had, I think there were 7 people working together in Omniverse during that live stream. Now that's just on Yumi's own platform, and they set it up there so that they can conduct training. But it was a really good show and tell about what it looks like when you have 7 people working on the same scene together. It's crazy what they were able to build in a little kitchen scene in literally about 20 or 30 minutes. Really, really powerful. So you can imagine in a working environment when you have lots of different people with different specialties being able to come together, not only be able to work and without losing data if the people using it at different times, but also being able to work at the same time in the same scene. One person will be working on one thing in the scene, the other person the other thing in the scene. So really, really powerful. Yeah, I think so. That's kind of in a big nutshell, what Omniverse is. And like I said, it lets you work in your existing apps and DCCs. So there's a Unity connector which was just released recently. It's in beta. We also have an Unreal connector, which is way outside of beta, so it works very well. We mentioned Blender already, Max and Maya, of course. So you can work with all your different DCCs or digital content creator tools to basically, some people are using Omniverse for rendering, but so you can kind of work on something in Blender and leverage the Omniverse's speed and rendering to render in the app or the tool we have called USD Composer, formerly known as Omniverse Create. But there's lots of different videos on our YouTube channel explaining different workflows, different apps. So I would check there. And obviously, you can go to omniverse.nvidia.com. That'll bring you to the main page. It explains everything. We do not. So Will's asking if we have a video for setting up Omniverse on Azure. I think that's in progress. I'll double check right now. So that doesn't mean that you can't do it. That just means you might not have a tutorial video for it. But obviously, you can probably follow along in the AWS setup and kind of imagine the steps for Azure. But I'll double check. It's a good question. I'm sure that's we don't have it, I'm sure it's very close to being ready for people.
Thanks.
Yeah.
And while we're just talking about a few things, I wanted to make sure that we mention next week, Jen and I are going to be doing an extra special live stream. We're going to take 2 hours and we are going to show you how to set up a scene in an Omniverse and how to write an extension for synthetic data generation that lets you teach an AI to recognize scratches on metal car panels. It's really cool. We showcased a video on GTC and it's been quite popular. And so we're doing a deep dive in next week's EDIO, and we'll take you from I just have a blank scene all the way to I have trained an AI to recognize scratches on metal panels. From end to end, we're going to go through all of that, and so that you guys can do it too. So it'll be, so we'll be showing off defect training. So it's to Zia's question. And so I hope you'll join us, and it's going to be a good one. In the meantime, we've got 15 minutes left. I think that's enough time to finish the DAC extension to the point that we are ready to extract load cases for topology optimization, which is kind of the goal here. So we're just one step away from extracting those load cases. And that is, we just need to know the angle between this link and between the crank arm. With that angle, we'll be able to apply the loads we need. So let's do that. And then we're at a really good stopping point. I'll wrap up this and publish it as a repo. I'll share the resources, all that. So let's see here. Let's dig into it. Let's take this. Let's see. Do we need the? I don't think we need the acceleration and the force plot. I don't think we even need the force plot at all. So I'm gonna. Yeah, I feel like it looks exactly like the acceleration plot. It's just 200 times bigger. So let's ditch it. And let's put it at the bottom here. And then we're gonna let's call it that angle phi between the crank arm and the transmission link. We got phi plot and phi data. Phi data. And then, what was it? Which one did I get rid of? I've still got the acceleration plot. And I've got the acceleration data. There's phi data. That's looking good. And so wherever we had, what's your problem? Over indent. Nah, it's, oh wait. No, that's fine. It's just being whiny. Oh, there we go. That's better. We got phi plot and phi data. So wherever we have did I mess that up? Oh, I'm struggling. I want to get rid of theta plate. There we go, right here. That's the one we were trying to replace. I'll have to fix this again. Let's go. We've got phi plot and phi data. Let's actually search for this one. Make it phi data. Oh, shoot. I messed it up. Try again. I'm struggling. Phi data. Place all those. It's supposed to. There we go. So now when we run it, we should get the plot should work. Oh, it didn't work. Let's clear this and hot reload and see what the error is. Oh, I don't know. I don't know what happened. Okay, great. This plot's working. It's just the wrong numbers at the moment. So let's calculate that angle. Let's see. Let's give it the same range as this other one, as the theta plot. Or we can go like, let's just start there. We'll see how it looks. Probably within that range. And then right here, if you recall, we've got A already, which is, that's the position of, which one? Of that slider, pin to the slider. We've got B, which is the pin to the crank. And where's C? Oh yeah, and the crank itself is at 0. So we just used 0 for it. So let's go through here. So if we look at this, This is A, that white dot. This is B, and this is C. AB is just 0, 1, 0. And then, excuse me, AC is 0, 1, 0. Right? Just goes along the y-axis. AB is right along here. So we are going to go the dot product between BA and BC. We're going to need to find C. So we'll see if we can finish this in the 10 minutes. We might not be able to. That sometimes I have trouble with that. Let's just pick that crank and see where it's at. We need it to have a rigid body. Oh, but it doesn't move. Does it have a rigid body? It does have a rigid body. That's good. Does it have a transform? It does. It has a transform. The problem, I think, if we go to our perspective camera, oops, we got to watch out for is the crank is down here. These pins are up here. And so we've got to kind of, on this crank, we'll grab the X and the Y position, but we're going to ignore the Z and make the Z 0. Let's see if that's what we did here. No. If we just make, let's see, we should do that here. We're just going to make the Z 0. I'm going to see how this works first. This basically just puts everything on that zero, on that zero plane. So we're kind of working in 2 dimensions. This should look essentially the same. Yeah. Looks good. So now, oh, that's struggling. Let's go back here. And we're going to say, we're going to copy this code here. It's the position of B. And we're just going to say, get the position of C. C transform, C success. I'm going to go through here. Oh, okay. Great. The only difference is now we've got to pop in, instead of going to geometry pin crank, we're going to go to geometry crank. And let's make sure it has a rigid body. It does. So we'll come back here. Instead of going to pin crank, we just go to crank. Let's see if that runs without errors. It doesn't do anything yet, but hopefully it doesn't get errors. Yeah, no errors. Good. Let's actually even, if we AC is, let's just see what this looks. I'm just curious. Is going to be C minus A. Let's try and debug and see. That should be 0, 1, 0 if we've done this all correctly. So this is like a good chance to debug because it's got a pretty easy value. That one. So let's attach our debugger. Great. And let's run the simulation. Yeah, I'll take that. I mean, it's not normalized, but it's almost 0. Like little number, big number, little number. Oh, it's negative. Oh, yeah, that's okay. I'm okay with that. And what we want to do though is A, B, oh, you know what? Boom, right there. I was already setting that third element to 0 by hand right there. That's okay. I think setting those positions to 0 in the first place is good too. And yeah, I like this. This is coming together nicely. And we'll say AC 2 is equal to 0 because it should be. This gets rid of any wobble. AB and AC are not unit vectors yet. So AB is because I normalized it. So now I say AC is equal to GF dot get normalized AC. Now AC is a normalized vector. That was Will's question. Both AB and AC are unit vectors. Yeah, because we're going for an angle between them. We want them both to be unit vectors. And so there we go. We've got AC. And we'll just say like, oh, E dot is equal to GF dot dot. Oh, I need some new ones though. We're going to say, look at this from the top. This is AB. This is AC. We want this angle right here. So we want BA and BC. Yeah. So let's go. BA is equal to A minus B. BA 2 is equal to 0. BA is equal to GF dot get normalized. BA. Now we're going to say BC is equal to C minus B. BC 2 is equal to 0. BC is equal to GF dot get normalized. BC. And phi dot is equal to GF dot dot. Take the dot product of those two vectors. BA, BC. And then we'll say phi is equal to math dot arc cosine phi dot. And actually, we'll do this after our theta calc. A little bit better organized. And then we'll say instead of putting that, wait a second. Oh, I copied that. I guess. We're going to append phi. Oh, it's breaking. Math domain error on line 190. What did I do wrong? We'll just step through, I guess. Let's just step by line here.
It's the moment of truth. Are you able to finish this in 2 minutes?
I know, right? Oh, it's not running my code. I got this caching problem. See how it's stopping at not my lines of code? That happens, and that means that sometimes it's like, do you just relaunch Omniverse or just VS Code, Jen?
I usually just resave a file, usually.
And that usually will clear it for you?
Sometimes. Depends.
Okay, let's see. It's not debugging it for me. See how it's not hitting my lines?
Interesting. It's definitely something to do with when you hit play that it's keeping that cache stuff. So usually in this case, you could.
Do I want to save anything in here? No.
I wonder if you just reopen the, or you could do that. I was gonna say if you reopen the USD file, if it.
Oh, just reopen the scene.
Yeah.
Yeah. Well, shoot. Now I've got 1 minute and Omniverse is launching.
And it's going to take 1 minute for Omniverse to finish launching.
I know.
Technically, you have about 10 seconds.
Ugh. Come on.
9, 8, 7, 6, 5.
Yes, I'm not
4,
going to make it.
3, 2, 1. Lift
It's
off.
going to go like 1 or 2 minutes. Just gotta try this, right?
Yeah.
We're
You know,
either
it's
gonna,
actually.
we're either going to end it with a triumph or a cliffhanger.
It's appropriate because you got the rocket ship launching in the background.
Yeah. Oh dear. Oh dear. Come on. Open. Come on. All right. Extensions, third party, crank slider DAC. And then go back to the viewport. It's all messed up now.
Are you sure this is the right one?
Yeah, because it loaded. What did I do now? That should be fee now. Let's open the code. We still got fee. And let's look at that plot. Fee. Why are those numbers all big? Fee should not be so big. Cliffhanger it is.
Yep.
We're out of time.
You're out of time.
So I guess next week we have our special edition. We'll go through some defect detection, and then the week after that we'll wrap this up. I don't think it'll take too long to figure out what's going on, and then we'll just take a look at maybe some topology optimization. Just kind of set this up a little bit and just talk about it. Should be cool.
Zia said it best. To be continued.
To be continued. That's right.
Really, I thought you were going to reference, is there an extension out of coffee directly to Omniverse?
Yeah, someone should write that. Should write that.
I'm still waiting. You guys keep talking about it, and nobody's written it. Come on, Zia. You gotta hop onto it. You got all these ideas about coffee, but I see nothing.
I gotta say, Jen, I was in a meeting the other day, and I saw someone with a bigger coffee cup than you, and I just was a little let down.
Well, when I'm at my dad's, I only have this one, which is my free Top Golf mug that I got on a previous company's stuff. But the mugs, when I'm at my place, I can show you my biggest mug if you want to see it.
Oh dear.
I just don't use it.
I'm a little afraid. All right. Hey, thanks for tuning in. We'll see you all next week, and hopefully the week after that, and the week after that. Right? Same bat time, same bat channel. And have a great weekend. Bye.
See you, everybody.